Hey everybody, this podcast is sponsored by Riverside, an online cloud-based recording studio that is just about as easy as it could possibly be for podcasters to record their interviews remotely. All you have to do is set yourself up with an account, create a new recording studio, email that link out, and then each person's audio and video will be recorded separately, which is a huge, huge feature because not only do you get the ability to process each person's signals individually, which is awesome for audio, but you also get to select how you'd like the video presented. And on top of all of that, everything's recorded in the cloud and downloaded later, which means there isn't a local recording looking better than the guest recording. Everybody gets the quality that's absolutely the best that they can. Now, I've been using this tool for a couple of podcasts now and absolutely love it. However, this interview with Mathijs was done back in December, and we decided to hold on to it until he had more stock available. That way we didn't talk about things that weren't available to purchase yet. So I still think this is a great example of Riverside because I want you to listen to last week's podcast with Justin and see and hear the difference from recording locally versus recording everything on Riverside. I still think this is actually a great example and great promotion to show what their platform can do. And as I continue to do ads for them, I'm going to show different features, different tricks that I've been learning, and other things that you might benefit from while using their platform. So please check out the link below. It's retrorgb.link/Riverside, and then use the code RetroRGB30 for 30% off a multi-month or yearly subscription. Okay, on to the interview. Hey everybody, I'm here with Mathijs, creator of the reverse-engineered Game Gear Motherboard. How you doing, my friend? Thank you for coming here and for doing this with us.
Hi, Bob. Hi, everyone. I'm here. Thank you for having me over. I made a reverse-engineered Sega Game Gear mainboard, or actually, it's a mainboard for the Sega Game Gear. Let's.
Well, you did more than that. You also made replacement companion boards to go with it, often referred to as daughter boards. And on top of that, I see you post pictures of a pick-and-place machine, which is the fact that you have access to one of those is cool. So let's just start from the beginning, because I'm interested in all of this stuff, both for why this exact project is important and also how this could be scaled to other things that you work on. So how did you get started reverse engineering a Game Gear motherboard?
Actually, I'm doing quite a lot of repairs on Game Gears because you have problems with leaking capacitors and broken LCD screens. So I was repairing them for just local people here. They were sending me in a Game Gear, and I replaced those parts and then ship it back. However, I had quite some issues with the sound daughter board, I should call it, like we usually call it a soundboard, that the capacitors were actually destroying the copper itself. So the board was unable to repair. So I started to reverse engineer this board. I've been doing this for quite a long time on Nintendo PlayChoice 10 arcade systems. So I knew I could do such things, so I made a scan. I actually reproduced the board. I started to, sell those boards as well.
Do you remember when you did that? Do you remember when you first reverse engineered the soundboard?
I think that's around 2 years ago, to be honest.
I might have bought one of those from you.
That could be the case, yeah. I first started with a reproduction of the original board, but I had a few customers which actually complained after you install a LCD kit. There is a step-up converter in it, and it makes like a tiny buzzing sound. And that's caused by a bad ground plane on the soundboard. So I actually made a new design which takes out that little buzzing sound. And they start selling those as well. And from one comes another. So
So that's
I
really cool.
also,
So how did you
yeah,
figure that out? Because like and I apologize to you and everybody listening. I'm gonna keep interrupting because I want to make sure that I get all the details from all the projects that you're working on here. So you first just reverse engineered the exact design of the soundboard for the Game Gear, and then through your customers, you found out that not your reverse engineered design, but the original Sega design would have issues with some of these screens because of the voltage conversion. So how did you figure out how to fix that to make your version of it?
yeah, it was a particular version of the board.
Mm-hmm.
So the first version of the Game Gear that was actually a 4-layer PCB. Um, and later, the second version, what we call the single ASIC one,
Mm-hmm.
it's a 2-layer PCB. And when you make a scan of the PCB, I saw that it had like a really poor ground plane because you simply saw that it was lacking it. like and I was something like, yeah, let's first, create the original board and then see, what's on. The original board works fine on an original Game Gear.
Mm-hmm.
There's no issues with it. But if you take especially the Chinese LCD kits, there you get this particular buzzing sound, which can be quite annoying.
Mm. So you increased the thickness of the ground plane?
No, it simply isn't there. Like
Oh.
there is a.
I heard Tito mention that in his video, and I was like, I wonder what he meant by that. Yeah, that's very funny. Okay, so you added a ground plane layer so that you could filter a lot of the stuff out through that.
Yeah, actually, and the thing is, with the first version, because of the 4-layer PCB, they had the inner layer set the ground plane there.
Mm-hmm.
But then they switched their production over to a 2-layer, and they simply left out this, the ground plane. And I think because of that, it's lacking. And you see in the later version, in the V4, V5 model, which is only available in the US, and their ground plane is back in. Like I think they saw the actual issue, but yeah, I think they sold so many units already that they didn't really care about it. But at some point they saw the issue.
So could that be one of the many, probably multiple reasons why some revision Game Gears, even completely stock, were just noisier through the headphone ports than others?
Yes.
Because I assumed it was wear and tear, but when I started to get into recapping, and especially my friends that do a much better job at recapping than I do, I would play around for a few minutes with a fully refurbished Game Gear, brand new caps, professionally done, and some would be fine, and others I'd have my headphones in and I'd hear that weird hum, and I just assumed that, like with many Sega products, there's so many different revisions that there were just mistakes in some, and I guessed correctly. So.
Yeah. Like if you have the V1 revision, and then most likely you have a bit of buzzing in it, and that's I had some people complaining about it, and I think it's fair, like before it wasn't doing it because without the LCD kit, you will notice it, but it's not that loud. But if you put the LCD kit in it, you can actually hear it pretty bad.
Now, your replacement soundboards will fit in any model Game Gear, right?
Yeah, actually, there are two different type of connectors.
Mm-hmm.
So in the early versions, which are only available in Japan and Europe, or let's say different, in the versions that are only available in Japan and Europe, you have this Tyco electronics connector,
mm-hmm.
AMP. That one I sell, but in the US models, you will find a JST connector, mm-hmm. which is, I think, more common these days. And I also sell those. Like a lot of other boards available, replacement boards only sell this Tyco connector. Mm-hmm. But if you leave me a message, I also assemble the other one, the JST one, because they have both available. So that's basically the boards will work for any version, any revision of the Game Gear. So it only depends a bit on the connector.
So just to clarify about that, then, if somebody were to cut the end off of their wire inside their Game Gear and solder it directly to the board, the connector wouldn't really matter, right?
Yeah, exactly.
And
Yeah.
to go back to your customers, it might have been totally plausible that they had a Game Gear that originally had the better soundboards from the factory, and then the caps leaked and it died, and they put yours in that was the copy of the other one and got the buzz. So it was actually
Yeah.
really good feedback and development that some of your customers were able to give you that info. So that's pretty cool.
Yeah. Yeah. That's at some point I also started to notice this, like, oh yeah, this is not good. And I also noticed that it only was happening with the Chinese LCD kit, like the other LCD kits had the issue. But I think this Chinese import, they simply take the cheapest of the cheapest
Yeah.
parts they can find. So yeah, but personally, I don't prefer using them anymore. But yeah, if people are using them, I recommend you either take a first revision soundboard or buy a new one. That's
Yeah, I mean that's actually that's a very common practice in that a lot of companies in China just say, well, we have the price advantage. You know, we do the manufacturing here, we get everything ready here, so we could sell them cheaper. So how could we sell them even cheaper so that people have alternatives? So yeah, they use lower quality parts, and sometimes it doesn't matter, and sometimes like this, it absolutely matters. So I always like to be very careful because uh, nerds in the tech world, when you hear things like cheap Chinese clones or cheaper Chinese manufacturing, we know what we're talking about, but a lot of other people take that as like, why are you saying Chinese people make low quality stuff? That's not what we're saying at all. But I want to make sure that everybody listening of all skill levels understand that. And I don't think it's always a bad thing, but if you're going for something that you want higher quality parts, you want to make sure that it's made wherever in the world that it's made with the better stuff in it. So in a lot of, I mean, you've just proved with the soundboard design too, that sometimes if there's no other option than the cheaper ones, as long as you have everything else around it high quality, it could sometimes compensate for that. So you adding the better ground, or you adding the ground plane and the build quality could sometimes compensate for those cheaper LCDs. But I do think that if possible, people should aim for the better quality ones.
and this also like one of the fun things you just said, that I have a PNP machine at home. Before I had my assembly done in China,
Mhm.
and one of the things I notice is when they don't have the parts available, or I think when they have their PNP machines fit with a cheaper part, they simply assemble the cheaper part on it, or the other part, let's say like that, the other part, which you didn't request. That's something that happens quite a lot in these small prototype assembly plants.
Mm.
Because if you look in the PMP street, like you need to have those parts available. You cannot just like keep on swapping those parts. So uh, you I assume they simply put other parts on your board which have the same specifications, but it's not what you asked for. that's
Yeah. Yeah, we ran
that's
into a
that.
problem years ago. I worked, I'll make this short because I've told the story a bunch of times, but I worked for a company that designed medical grade computers. In the internal DC to DC power supply, we got rated. It was, we paid a lot of money to get it certified for use in medical use. And we got maybe 100 prototypes that were flawless. And then we did a first manufacturing run and we started releasing them into the field, and a bunch of them just started dying. So we got it back and we realized that the company making the power supplies did exactly that. They swapped out the capacitors for cheaper ones and a couple of the other parts on it that looked almost identical, but they weren't. And we had to go and we had to send a team of people to replace 5,000 power supplies in computers. Some were still in a warehouse, luckily, but some were on site. So it's just, wherever you get your stuff made, you have to do good quality control, or get a pick and place machine yourself.
Yeah, that's so at some point I made the decision, like yeah, like I'm done with it. Also you pay quite some money for the assembly, even though it's in China. uh,
Mm,
and why not do it yourself? Because in the end, it's not that much of work to set the machine up, and once it's set up, yeah, you can easily assemble 100, 200, 500 ports. So small production runs, which yeah, for me, that's the perfect solution.
I did actually have the opposite experience. For a very short period of time, I was selling those RGB boards based on board use design for SNES Mini and N64. And every time I did a new order, I would install one. I probably should have done this in the opposite order, but I would install it in one of the two consoles, an N64 or an SNES, and I would test it that way. And I never once had one fail. And then afterwards, I would remove the components to double check that they were the 1% tolerant and everything. And I never had one fail from the factory, and I never had a batch that had bad parts on it. But we're also talking about a component with one THS chip and like 4 SMD components. So, it's not like a design with a ton of components on it. So it's, I guess it's all, I know we're getting a little bit sidetracked here, but I guess when you're making stuff, it's all about quality control. Whether you make it yourself, whether you have somebody else make it, just make it very clear when you're talking to these manufacturing houses that, hey, in this contract, let's say that I'm going to test 1 or 2 out of every batch, and if they're bad, if you switch the parts, I'm sending them all back. You're paying for shipping, and you're making the other one for free. And I think when you politely put those terms in, that they know that you mean business and that you're not just here to get some cheap part made. And I've had very good luck when I politely put that in the terms that I will be checking every one of these things. So it's all about quality control, because you could do the same thing, right? You could not be paying attention, accidentally order the wrong part. It looks the same, so you throw it on your pick and place machine, and then you've just made 100 of them with the wrong part. So it's all about good quality control.
Definitely check all your parts you receive. Yes, that's.
I've done that before, hand soldering things. I think I had one thing where I used a 750 ohm resistor instead of a 75 ohm resistor, and I put this complicated board together, and I couldn't figure out why I wasn't getting any sync on the screen. And then we kind of went through, and one of my friends was like, "Is that a 750 ohm resistor?" And I went, "Oh, moron!" I only made one though, so that was a little different. So I guess since we're talking about it, we'll swing back around. But how did you end up with a pick and place machine?
Yeah, because either they couldn't supply those parts on the board, or they simply swapped it out with different ones. And then I had the challenge because the Sega board, it has a custom chip from Sega, which you cannot buy. Like I would love to buy a tray of it, but too bad I cannot buy them. So I desoldered them, and it's a QFP 144. So it has a tiny pitch. So you need you need to sit down a bit and then do the hand soldering. So I decided I want a pick and place machine that can actually mount the Sega chip. And then you ended up at a bit more high-end machines for prototyping.
Those are really expensive though, right?
Yeah, they cost money, yes.
Because I had a friend that looked into one, and I think he was going to spend about $20,000 on one to make his own boards. That's a lot.
That's around actually it's a used machine. So about it, it's 2 years old. And they were doing also like that factory was doing small run PCB assembly, but like one of the things is as soon as you start working with such machines, you run out of feeders. Every feeder can hold one component. The one I have has I think 48 feeders, so we can place 48 different components in there. And as soon as you start with a small run of assembly, you will run out of the parts. You need more parts. Then you have the decision either to buy a second machine in line, or you buy a bigger machine. So they went for the bigger machine, and they put this one on sale, and found it. Contacted the guys, and they said I want to have it because it fits my for me it fits my requirements. It's not that big, I bought it, and actually, it's doing exactly what I wanted it to do, and I think that's great.
So if people want to see it in action, I saw that you posted short videos of it on your social media, so people could actually watch this thing go. But I've seen them in person. I've obviously worked with companies that have used them, but I've never programmed or used one myself. So I'm kind of interested. When you said it had the 48 trays, so does that mean everything that you manufacture can't have more than 48 total components on the board?
Yeah, you cannot have 48 different type of components. So you can have like there are simply uh, 5,000 resistors on one reel,
Mm-hmm.
but so you can every time it will swap next to the next component in the tape, but you cannot have more than 48 components there. Different types of one. So when you assemble the board, you start to look at where can I reuse resistor values, where can I swap some capacitors, like that you end up with the same components, maybe a bigger spec, but it has the same value, like these kind of things. And it's the same like some parts they are like the 0603 resistors, and some parts are the 0805. But if you have the same value on the board, then you simply swap the footprint to the bigger one. So it's all good. So you need to think a bit more efficient, and the assembly, not when you design the board that is everything according to what you calculated, but everything you need to think about how it fits in your assembly as well.
Yeah.
Because you're limited in the amount of components you have.
That's a very big advantage of making things in quantities of hundreds or thousands as opposed to hundreds of thousands or millions. Because if you have 300 ohm resistors and one only requires 5 volts and the other two require 10 volts and 20 volts, you could, on a smaller run, just have 3 100 ohm, 20 volt tolerant resistors on there. And if you lost the 45 cents total per board or something, it doesn't matter. But if you were making 1 million of those, that's a lot. That's $500,000 lost almost, right? So we in our smaller, indie runs of production get to do things like that. And same thing with the size. If you want, if all of the components are or have the correct tolerances, you could use all smaller ones instead of bigger ones. And, same thing with capacitors, right? You could use, as long as it's the correct capacitance, you could go up to a 1,000,000 volt tolerance and it doesn't matter. So it's kind of neat that we have the ability to do that. Whereas bigger companies, there's no way, they would just lose money for no reason. So.
Yeah, exactly. Like, and for me, I would be losing money, by having wasting multiple feeders, because it's possible to, you can tune things in the machine a bit, that you put like things on a tray.
Mm-hmm.
So you can fiddle around with the components a bit, like how you align them. But still, yeah, in the end, you need to try to make one program and let it run one time instead of that you swap components and maybe do a second run, because that's also possible. But that's simply a lot of work to do, to swap those components from the machine. So
yeah, that's actually the other question is, can you do 2 runs? So can you send a board with 100 components, so double or let's just say 75, right? So you send them through one run of production and then swap the parts out, and can you send them through a second run to populate the other side?
Yeah, it's possible, but then you need to swap the components every time. Actually, what happens then is they buy a second machine, and because it's a conveyor, you simply let it run to the second machine.
Oh, that makes sense. So you at home might do 2 runs, but a manufacturing company would either just get a bigger machine or a second machine because it would be way more efficient if that's your job, is just making boards. So
yeah. They have a line of machines next to each other, and they're simply placing parts on all the boards.
That's pretty cool. Have you ever seen the wave soldering machines?
Yeah, I've seen them. Yes,
that's those actually, are nuts.
I have a very small one. Sorry, no, I have a small reflow, but yeah, like the company where I bought the PNP from, they had a wave soldering machine, and they actually had almost a full assembly line for what they were doing. So that was cool to see.
Yeah, I saw one of those once because I was in Taiwan, and they were giving us a factory tour, and I said, "Oh, let's see that." And I think I think they thought that I was like an expert and wanted to check that they were using a good machine, but I was just a nerd that wanted to watch the machine work. So they brought me through and showed me. I was like, oh, that's awesome. All right, thanks. So, well, that's incredible that you do that. And I was just so curious about that. But I guess let's swing back to the boards itself. So you did the soundboard first, and then I believe you went on to the power board, right?
No, actually, the second one, because I'm repairing a lot of game gears, and I also like at some point you see that the capacitors simply eat all the copper, so the board is no longer able to repair. Like you can make new traces, but at some point it starts to fail again. So I stopped doing that. I simply told my customer like it's over with this one. I will sell you a different one. But I had a stack of boards, starting to grow. So I knew I could do this with the Nintendo Play Choice, and with the soundboard. So I thought, like, let's give it a try with the Sega Game Gear main board. And but actually it worked out. Like it's.
So did you do the Play Choice first or the Game Gear first?
I did Play Choice years ago. I had the same thing with the arcade. The old arcades, they start to rust because they usually stored in a bad condition, and then the IC sockets start to rust, and that's also giving a really bad damage to the board. So I had a few of those boards, just stripped all the parts, made a scan of it, and then you retrace the original board because there is also no schematic from it, like. So you need to do something, and I think I did all boards available for the Play Choice 10, and I also did the main board because back then also people started to contact me like, hey, can you also do more? Can you do the main board? Yes, I can do the main board.
So, I mean, that all of this sounds like a huge undertaking. So, in order to start doing this, you would first have to get a list of all of the components on the board, right? So,
yes.
Doing that manually, doesn't that require you to take off every single component and measure them?
Yes.
And then how, for things like capacitors, where its capacitance decays as the part does, is there a way to verify which one was supposed to be there versus whatever part was broken when you were removing it?
It's sometimes you have schematics, sometimes you can read it, the little code on it. Other ones you simply measure with a LCR meter. That's that's a bit of it.
That's nerve-wracking. So every single component you have to measure, mark off, and basically make your own bill of materials, your own BOM for it. And then after you remove every single component, then you put it in a scanner to scan the traces on it, correct?
Yes. I make a scan of the board, and that's also fun. Like you have two types of scanners. I don't know if you're aware of that. We have a scanner that simply has an optical lens, and that's like one small sensor, and it stretches out the image. But there is some distortion in it, so the image is actually not correct what you get. And that's for most pictures. If you scan a photo, it doesn't matter. But if you're scanning a PCB, you need accuracy. Like everything needs to be correct. And that's like one of the challenges I had. And then I came to I was reading a bit about scanners, and there is also like the very cheap scanners, which are simply USB powered. They have an image sensor over the entire line, so it simply drags this entire big image sensor over the entire scanner of the plate, and those ones are accurate. So the cheap ones, the really cheap USB powered, those are CCD scanners. You can use those for scanning PCBs.
I never knew that.
That's and then you can scan it. And once I have the scan, I do some photoshopping to change a bit more contrast, to make it straight, all those kind of things. And I'm then using the software from Abacom. It's called Spread Layout. I don't know if you know it.
No.
but it actually has the option to set the scanned image as a background. And then you can place the pads on, the scanned image, and you can retrace the entire board.
Okay. So now I'm assuming you could only do this with a 2-layer board because you're not separating the layers and seeing in between them, right?
Actually, the software supports 4-layer boards, but I have no clue how to separate a 4-layer board.
And I mean, for anybody that's unaware of this but curious, 2-layer board is as literal as it sounds. 1 layer on the top, flip it over, and there's another layer on the bottom, and the traces just go, and you could connect them through with through holes with vias. So, and then 4-layer boards is usually multiple layers, and then you have a layer that's a ground plane and sometimes a layer that's a power plane, depending on how you want it set up, and that gets way more complicated. And I started looking at a schematic for a 6-layer board years ago when I was trying to find a ground issue, and it hurt my brain. So I think that's my limit, is looking at schematics. I think four layers is about all I could do, and I'm not even good at that, by the way, but
also,
but that's pretty cool.
Never worked on those. Yeah, that's that's maybe a next level. We're good with 2 layers, but yeah, still, I don't know how to separate actually, 2 boards. I've read on the internet it's possible with some chemicals, but never gave it a try, to be honest.
So when you're doing this stuff, then, so you create your own bill of materials, you measure every single component, you mark off the proprietary components that are only available from that company. You did the scan, you set it as the background, and you basically traced in software over the original traces and layout and where everything went. And then in order to make replacements, you would then take every part that's still available over the just basic on-the-shelf parts like resistors, capacitors, power components. And for the PlayChoice 10, you would just fill all of those and then leave the stuff that's Nintendo only empty. And then that way you could create a replacement so if people have a dead board, rather than trying to repair traces, trying to fix leaky capacitors that burnt through the motherboard, you could just remove the main components on it. And that would be the same theory for the Game Gear as well, right?
Yes, yeah. Correct.
Then did you sell populated PlayChoice 10 boards, or did you just sell the PCBs, or was that more of just a reverse engineering project?
I did reverse engineering, but the PlayChoice 10 is not as popular in Europe. Actually, you rarely see them. But in the US, I think they're actually pretty popular.
Yeah.
And so I'm not selling any boards here, but I'm shipping them to a guy in the US, and he's populating them and selling them.
That's very cool. I will get links to all of these things from you when we're done, and I'll make sure that anybody listening, wherever you're listening, you have links to all of this stuff if you're interested. But I think there's probably a whole bunch of people that have PlayChoice 10 machines that are giving them trouble that would love to do this instead, because, it's brand new and original at the same time. So
yeah.
That's very cool. So then after you practiced on the PlayChoice 10, which is nuts because that's a bigger board with more components, did you find it easier to do the Game Gear because you already had all that experience doing the PlayChoice 10 first?
Actually the boards from Nintendo, and that's, I think, with all the boards from Nintendo, they are so nicely designed. Like they really work on grids. Like they are, when you look at the board, they are a bit self-explaining. And then you have the Sega board. This one was pretty hard to retrace everything because they don't work on grids. Actually, they work on grids, but they actually mix 2 different grids on one board. So yeah, that's really like they were going from a grid from 0.35 millimeters to I think it was 0.2, and that was happening somewhere in the middle of the trace, and that makes it really hard when you're retracing, because you expect something and then you think, oh, I made a wrong scan, and then you start to line things up again, and then at some point I came to the conclusion, hey, at this point they're simply changing the grid. But where does it stop?
Yeah, that's so
Like, where
strange.
does it start?
What would the
That's
purpose of
really
doing that be? Why? I don't understand why somebody would do that.
I don't understand. I think they had some issues with the with the the dimension of the board. I think they couldn't fit enough traces there. And I think they got into an issue, maybe, later in the design, like, oh yeah, maybe we need to add this, like something like that.
So rather than go
And
back and redesign it the right way, they just fixed the one or two things that they needed to fix in order to make it work. That sounds very
yeah,
Sega. That sounds like a very Sega thing to do.
it's also like it's a second revision of the board, so they went from a 4-layer design to a 2-layer design,
Hmm.
and the form factor was already there, so I think they couldn't make the console any bigger. It had to look the same as the previous revision. So I think that's why they did something silly with the grid, because it's exactly on the. So when you look at the Sega PCB, this one is exactly on this narrow side where they changed the grid.
Huh.
and when I did the when I did the scan, there were actually more traces there. So I removed a lot of components, and I could remove a lot of traces. So I freed up some space on the board, but because it had like an old LCD, there were more traces there. So I think that was their issue. But yeah, we will never know unless we ask Sega themselves. But I don't think they will.
It's funny. All the stories I've heard over the years of people asking original Sega engineers questions like that, the answer is usually, I don't know. We did what we had to do to get it done. I don't remember. So it's it's kind of cool. I mean, they were the underdog. They got a lot of this stuff done. When probably people didn't expect them to pull it off, and they were. So they get a lot of credit for that. But also, looking back at some of these things, there's so many. I'm not even a board expert, not even close, by the way. But there are so many things even I've seen that I go, why the hell would anybody do that? It doesn't even make sense. So, yeah, I guess whatever it took to get it done is what Sega did to make it happen.
Yeah, that's really like sometimes when you look at the scan, then you think like, what is this even doing? Like, what's the purpose of it? And I think you will never. That's what you say. Like, I think they did to make it happen. I think also the competition was very big with Nintendo, so I think they did everything. Yeah.
So on the Game Gear motherboard that you designed, you'd removed all of the components that had everything to do with the original LCD screen, which I think was a really good move, because if somebody wants an all original restored Game Gear for whatever reason, nostalgia, archiving, whatever, then yeah, take the time to revert or to replace all the caps, to clean up the original motherboard, use the original screen. If you find one with a motherboard that's too damaged, pick up another one, so that, and they're cheap enough where you could do that, especially if you're willing to put so much time and effort into restoring the original. So I really like that you approached it from the opposite, because I don't think there would be any reason to have an exact original replacement, because it's still not, it's technically not original. So if somebody wanted to archive this, to have it in their own personal museum in their house, they're going to want the original board. But if somebody wants to play a Game Gear, to actually sit there and play it and enjoy looking at a screen that you could see, you're going to want to use a modern option, and you don't really care about stuff like that. And rather than spending 8 hours cleaning up, corroded traces and rerunning traces, it's, for an expert, it's actually much easier to replace those chips and put it on a different one. So I think that was such a good move, and I think that was the right thing to do. But can you talk a little bit about the decision to do that? And also, I think you said that you had the original scans that you were at some point going to release in case somebody ever did want to go and just for archival purposes have the original traces.
Yeah, so I actually have a few boards that are simply a reproduction of the original, because I did a retrace of the original board, so I have the Gerber files. And actually I want to publish them because they are very useful when you want to repair things. Like you can simply click on the trace and you see where it starts and where it ends. So for that purpose, I want to release them. And actually, I have a few boards, but I did not even take the effort to assemble them, because I think, yeah, then you're stuck with it exactly with an old LCD that I think nobody really enjoys playing with when you have like a new machine. Like, so that was for me also, like I wanted to make something which was having all new parts except for the few custom parts. Um, and that's, I think, fun about the Game Gear. I think when 1 year ago, Retro 6 released a new shell for it, which is also great. I thought, like, I can simply make a Game Gear with all new parts except for the ASIC chip, the cartridge connector, and the silly extension port connector, which is also custom. And yeah, for the LCD screen, there are kits available. Like I don't even bother to create my own kit, because I think the kits which are available, they're good. Like they don't need any improvement. So I simply wanted something that fits in the what's available today. Yeah, so that's how it ended.
So that makes sense. The LCD kits are good, all the ones that I've seen. However, I don't understand why. Maybe I'm missing something, but if you take the Game Gear's resolution and you multiply it by 4, isn't that 576p? So isn't that a standard European resolution that you might find? I don't think there's any
Yeah,
LCD. I don't think anybody's made a mod that just, quadruples scales the image exactly 4 and then sends it to one of those. It could be screen availability, because the only 576p screens I've seen were like 10 inches, not, whatever else. But I think that would be kind of the best, because, or I guess what the Analog Pocket's doing, and scale it 10x and, to something like that. Because I do think there's some issues, and Tito goes over all of these in his videos. So if anybody's wondering what I'm talking about, just check out Macho Nacho Productions and watch the Game Gear videos. But I do think there's still room for improvement. And of course, the ideal perfect world solution would be if somebody created OLED screens that were the same size and the exact original resolution. But I don't think anybody's going to do that. Just saying, there's always room for improvement. But the important thing that's relevant to your project is, it doesn't matter. You have the pads available for people to add any LCD screen, and it's their screen that adds the components, that does the scaling to whatever chip or to whatever resolution screen is in there, right?
yeah, correct. And like I got a lot of feedback about that I should add like things like a HDMI out or a VGA out. But the thing is, the board itself doesn't do that. It's always the aftermarket LCD kit that changes the video itself to to this new LCD, a normal LCD. So the HDMI out, I cannot. Then I need to basically do the same thing as what those LCD boards are doing. Like
You would need to design a scaler for the Game Gear from scratch and integrate it onto your board. It's way harder than just like, oh, I'll throw an HDMI chip on there. It doesn't work like that. You have to translate all of the video signals to do that. However, I do see an opportunity for that, because the link port is cool. I think I've used it once in my entire life, including when I was a kid, when I had a Game Gear. But that's a spot that's now open for whatever you'd like. So you totally could put an HDMI port there if you wanted to, and it allows you room to grow. But that's a lot. So unless somebody had an open source design that they were willing to offer you, then I just wouldn't. I don't know if I would go through that much trouble, especially when there's so many other options available. But I mean, you never know. Maybe a couple months from now, or maybe somebody's going to be listening to this and say, I've been working on a Game Gear scaler. Here, just I'll open source it, take it, throw it on your board, and do that. And that would be cool. But I don't expect you to write that from scratch.
No, yeah, that was also not my plan, to be honest. I have some experience with programming microchips, but not at that level, to be honest. So that's yeah. I think that for such things, I also need to develop myself more. Maybe who knows in the future, but right now.
Yeah, but something like that being open to collaborations is pretty awesome, because if somebody, now that you've removed all those unnecessary components, there's a lot of room on that board to do other things. So if somebody does want to step up and partner up with you to make their project, this is the perfect platform to do it, because you could do whatever you want on the board from scratch. So
yeah, that's exactly like I because the Game Gear itself, it has like a gap. There is like I can simply have the entire board. You don't need the gap. Actually, the fun thing behind the gap is I produce everything in one.
Oh, that's neat. So that it all rolls out, and then you just snip the other boards out when you're done, right?
Yeah. So I make a one panel which has the main board, the soundboard, and the power board. And that's actually also how Sega did it back then. So I simply, stole their ID.
That's really cool.
And so I create everything all at once, but I could also fill that gap, and you can place things like either an LCD kit on it or like a cartridge emulator, like a EverDrive type of thing. But yeah, like I think the options are endless, because you still have a huge base available on the main board. So there are things possible. But yeah, let's maybe somebody is willing to work with me. I'm talking a bit with Ben Van.
Yeah.
And he also sees options, but yeah, this maybe in the future,
Yeah, that would be very cool. I interviewed Ben a few years ago. It was he's got a lot of cool things that he works on, so it'd be neat to see this done.
Yeah, I think that would be cool to have just one single board rolling off the shelf, where you just put the ASIC on. Don't even bother anymore about the cartridge connector, because there we can do a cartridge emulator there. Have the LCD kit already done, and the only thing you need to swap is the ASIC, and then you basically have a brand new board.
That having the cartridge slot being optional would be ideal. So if somebody just wants to play ROMs, stick a micro SD slot in there somehow. But if somebody does want to go through the trouble of adding it, that would be cool. And that way you would just need an auto detect circuit, so that when the cartridge is in, it disables the other thing. But yeah, I think that would be absolutely awesome.
Yeah, because I think you're able to probe to see if there is a cartridge, if there is a cartridge inserted in the board. I think if you probe a few pins, you can actually see, you can see if there is something there or not. So, and then you can switch between the emulator and the cartridge itself. But yeah, it needs somebody has to take a look into this.
Yeah, that's pretty neat. And for the power board, it was just an exact copy of the original. Did you look into any of the modern component replacements for that?
Yeah, so I first wanted to do like a power board that was pretty much giving the same options as the original one, only with more modern components. But I had the issue with the battery springs. Like, they're also non-standard, and that would mean I had to ask, a Chinese company to create new battery springs, and you're looking at mass production again. And I had something like, why even bother with the battery springs? Because I can also connect like a LiPo battery to it, and save myself the trouble of sourcing battery springs. so I redesigned, or I actually created a new board with a USB-C instead of a normal DC jack, and a small cable with a JST connector to it, which pops out any battery component, and from there you can connect the battery. So it has a voltage regulator on it, has a charger chip on it, and it's pretty simple actually.
So with this design, you don't use AA batteries at all anymore. You just don't put anything in there. You use the battery that you included on the inside.
Yes.
And that also allows you to play and charge at the same time.
Yes, correct. Yeah.
Very cool. Huh.
And it gives also the option, to connect a standard USB-C, which I think everybody has these days, instead of, the old Sega brick, which
which those themselves are aging, and the capacitors I've seen go in those, so that's why I always recommend the triads. But that's a $20 power supply, after shipping and everything like that. So to have USB-C built in, you're right. I think even if people don't have the cable, everybody's got some kind of higher powered USB charger. So to order a $3 cable is going to be way easier for that. And it also makes it lighter, because a Game Gear with 6 AA batteries in it is way heavier than something with just a lithium ion battery in there.
Yes, and also, like, back in the days, a Game Gear was lasting a few hours on 6 batteries. I think that was one of my problems when I was a kid. But the thing is, after I removed all components, and also I'm using like the modern LCD kits, I reduced the power consumption of the Game Gear itself a lot. So with a very small LiPo battery, we've been doing some tests with a 2000 milliamps one, and the Game Gear lasted for more than 8 hours.
That's a huge difference.
Yes, that's even more than on an original one on 6 batteries. So and it makes the console a lot lighter. Exactly. Like, so we also did a test with the Retro 6 battery kit. They also provide a LiPo battery kit, which has 2 batteries of 3000 milliamps, and it lasted more than a day. So that's for me, that was a bit, like, I think one day is great, but it's I think 8 hours was sufficient, to be honest.
Jeez, that's awesome. So now that this project, the single ASIC reverse engineering is pretty matured, what are your next things that you're working on? I know you mentioned potentially looking into the other model Game Gear motherboards as well. Have you decided to go ahead with that, or are you still just deciding?
At first, what I want to is a bit more optimization on the assembly. Mm-hmm. And that's mainly because currently the soldering the LCD kit to it, I think that consumes most of the time. I think I soldered the ASIC to it in less than 2 minutes. And actually installing the LCD screen takes more time, so I want to optimize that a bit.
I wonder if just a JST connector would work, and then that way you could make a custom cable for the LCD kits, so that way you only customers just plug them in.
Are you just reading on the BenFan Discord, or?
No, I've been making products for 15 years now, so my brain automatically goes to the most efficient answer.
So I put some, because I already have the pads. I aligned the pads in a way that they match with the BenFan kit. I put some holes in it, so the JST connector is there. However, the BenFan kit, it has pads, just solder pads. There is no GST connector or option for it. So I made a little PCB where simply you put it on or I designed it. I still need to have it manufactured. Which you simply solder it on the BenFan kit, and it creates a GST connector.
Oh, neat! Well, that's awesome.
So that's it's simply then connecting two GSD connectors together, and we're good. That's actually what was in my mind. It's also a bit low budget because it's like you can create a flex PCB, but for small quantities, those things
Very
are
expensive.
pretty expensive, and it doesn't give you the option to actually remove the kit because I have some customers who are asking like, hey, yeah, can you send me a new main board? But I cannot assemble the chip, so can you assemble the chip for me? But I think, yeah, then I need to test the screen, and the only way to test the screen that is to assemble the screen, you know. So I think I need something that I can also remove after I tested it. So you can do a quick test and then say, oh, it's working, ship it out to the customer. As that's why I personally prefer to have a GSD connector. There.
I agree. And these screens, especially for Game Boy Color, it seems like there was a new screen every other week for like a year, and there's more screens for the Game Gear as well popping up. So for the customer's end of things, being able to just unplug what was already there and plug in the latest model would be great. You know, that way it saves anybody with very basic skills, and a screwdriver could do it, as opposed to requiring somebody to get in there and solder it all together. So I love whenever there's the ability to do connectors. I love being able to do it that way without any soldering.
Yeah, so that's the new revision I'm making. So of optimization, I think the board itself already showed that it's working. So I didn't make any more changes to that, but I want to optimize, you know, like what you say, like the assembly and flexibility to do, you know, different screens and these kind of things. That's what I'm looking at right now. But yeah, and if you look at what I'm planning for the future is, it's definitely do something with the US model. So that's the V4, V5, and Majesco revisions. There is also no documentation about those. So for the first two revisions, the schematics leaked out. But for those later revisions, there is nothing. So that's also why I had something like, there's something I can do. So there's also something somehow I can support the community, by reverse engineering what's on the board and how the board is functioning. Maybe also make a schematic based on that. But that's
it's a lot of work.
That's a lot of work. And also the thing is, the later revisions are also 2-layer PCBs. So they're you know, that's something I'm familiar with, something I can do. You know, that's also things that matter, because I think the first revision is a 4-layer PCB, and then you get back to never done such things. So maybe if somebody can help me with how to, you know, separate those boards, I might be willing to work on those as well.
So I gotta ask, have you ever taken a look at the Sega Master System motherboard?
No, I didn't. I have a Master System, but I never looked at it. To be honest, when I grow up, I grow up with handhelds. So that is what. That is what.
Because the Sega Master System is so unique in that, you know, it has a lot of fans, especially in South America. A lot of people grew up with it. I ended up getting one randomly, even though nobody I knew had one except the kid who sold it to me when I was a kid. But it's unique in good and bad ways. You know, the bad way is that all of the US ones that I've tested, at least the original model ones, are laid out so badly that you can't fix all of the interference in it. You would have to reroute the motherboard. And, you know, there's some PAL versions that you could get some fixes. The SMS2, you could get it cleaned up. But generally speaking, they're all going to be noisy unless you do an insane amount of work, if it's even possible. But on the good side of things, there's so many unique things about it, like the FM sound chip, which was only built into the Japanese version or was an add-on module. The 3D glasses, you know, I think there's less than 10 games and only 4 of them are good, but they're really fun. And then, of course, there was the MK2000 carts, which you could get different stuff in there, so or different converters to play them. So I always had this idea, and people had started projects, but I don't think anybody had fully completed them, of reverse engineering that motherboard so that you could have something exactly like you did, where you just take out any of the proprietary chips or the more expensive ones like the Sony CXA. You could totally reuse that encoder if you wanted to, and have things like a Genesis 2 AV port, so that way you could use more common cables, have the 3D glasses port and back already built in, and maybe even instead of the expansion slot and back, have the MK2000 cartridge port back there. And that way people who have master systems that want to play on original hardware could just desolder the 4 or 5 chips that would be the most efficient and then put them in. But it's a lot of work, and people have come close. People have, there's one person on the SMS Power forums that did the open source design, but there was a bunch of things with it that weren't completed, and I don't think they ever swung back around to finishing it. So it's one of those things where I would never recommend that anybody do that unless they loved the master system, because you'll do 1,000 hours worth of work to sell 100 total maybe, whereas Game Gear you'll probably sell 1,000 of those. But if there's ever Master System super fans out there that wanted to work on that, I think people would actually buy it, but not a lot.
And talking about hours, when you start such a project, you use like it's a hobby, like if you do this commercially, I think it would never, make sense.
No.
So you spend, I don't know how many hours I spend on this. Also, like setting up the P&P machine, I was simply, taking a big jump because I knew the existence of the machines, but I never operated one. So it's really like if you're into such things, it doesn't. At some point, you think like, I want to make this work. So you spend a lot of time, really a lot of time in making something work. But commercially, it doesn't add up.
Yeah, I always joke that's exactly what RetroRGB is, and that like if I spent the same amount of hours on a minimum wage job sweeping floors that I spent on RetroRGB, I'd make 3 times the money. But if you love it, and that's something that makes you happy, cool. But I get it. These are passion projects that you do because you want to, not because you're trying to make money off of it. And it's good that you do to pay for things like a pick and place machine. But it's it is a labor of love, definitely.
Yeah, this.
So how did you learn how to do all of this stuff? Is your day job board layouts and engineering, or is this just totally a hobby for you?
At this, I actually work as a service provider engineer. So I design IP networks.
Oh, cool.
So, but I always I had electronics as a hobby since I was a kid. Actually, when I went to university, when I made the decision to which university to go, it was like either electronics or going to IT, computer science. And then back in the days, the jobs for electronic engineering, it was really bad here because in the Netherlands, we have Philips, and I was simply moving to China. Back in the time, so there were no jobs available, so I made the decision going for computer science instead of electronics. But yeah, the background, you still keep on soldering and doing all kind of things. But yeah, maybe I made the wrong choice. Who knows? The fun fact is that actually my wife she studied electronics, electronic engineering. But she went to IT.
Yeah, I mean, I think that's very common in that, if you like 2 things and you're going to do one of them for a living, you're going to pick the one that has the best career path for you as a whole. So, sometimes, unless you really love it, right? Like I love playing music. I loved being in a band, but like I I would probably be a stick figure right now, eating one meal a day of ramen noodles, and not having a CRT collection, not having a microphone. Like, I'd have to be completely poor if I wanted to only do that for a living. So you gotta choose what pays the bills and makes you happy. So it's it's one of those interesting decisions. But it's so funny to me to hear how many people that have become so so good and so recognized in the projects that they've done that they're just hobbies, and it's just kind of funny. Like, all of Voltar's boards, he never went to electrical engineering school. This is stuff he just taught himself. And it's kind of funny just to see, people with the desire to do something. That's all it really takes, is the desire and a little bit of knowledge, and you can jump right into it. And it's a lot of times their day jobs and their hobbies don't cross paths at all. So,
Yeah, that's exactly like it. The only the similarity I have with my day job is that I work with CAD tools, like to make the actual network drawings. There are some similarities. So you get aware of that you need to make accurate drawings, accurate like positioning matters, like those things. At some point, help you with creating a PCB layout. You need to see how things fit, and that's the same when you make network drawings. You need to see how things fit together, in one big picture, and that it also makes sense. But for everything else, no. Like,
well, also the mentality of IT and all of this stuff. So I'll tell you a story. My first job, corporate job, I was 19 years old, and I was the youngest person there by at least 20 years. And most of the people in the department were in their late 50s and early 60s. And one of the guys comes in one day, and he says, somebody came up with an idea, and oh, that won't work. And the person who came up with the idea said, you're always so negative. Why can't you get behind all these ideas? And the older guy said, my wife says the same thing. Every time she says, oh, should we go on vacation here? I always say, well, no, because it'll be crowded. And one time she yelled at me and said, why are you always so negative? And he said he realized his day job for 40 years is to open up the software and to figure out everything that could go wrong. So his whole life, subconsciously, every time he looks at something, he thinks what could go wrong in that scenario. So he then had to make a conscious effort to be positive. And that story always stuck with me for two reasons. One, because I want to make sure to not be negative when, then I always try to be a positive outlook. But also, he was right in that everything IT related and in board layout, you have to always approach it with, okay, what could go wrong? What could fail? What did the original design do that wasn't good? Like, let me pick this thing apart and figure out every little thing that could possibly be a mistake, whether it's original or my own. And so that is two parallel thinkings in board layout and in electronics design and all of IT, is you're always thinking of what could break, what could go wrong, how could I fix that? So.
Yeah, that's exactly like my day job is usually, you create something, and in the end, you spend more time, solving incidents, solving, things that are not implemented correctly. Like as a troubleshooter, you become really good in IT, because it's mainly about, troubleshooting and solving things,
Yeah,
and making the right decisions. And that's mainly where I, at least in my job, it's mainly about. It has very less to do what we learned at university.
yeah. That's why I'm certainly not putting down anybody that's going to college and learning all the extra skills, but you need the real life implementation and the experience on top of that, because some stuff there's no way you could be taught anything that happens when things go wrong. I had one company I worked for. I was young. I think I was like 23, and they were a sales company, and the internet went down, and because a pole was a truck crashed into a pole, so it was probably going to be 2 or 3 days before it was fixed, and it was in a busy season, so they would have lost millions of dollars. So everybody's saying, do we send everybody home? Do we try to do it over the phone? And I said, give me 5 minutes. I get an idea. And I took a couple of old laptops with the PCMCIA cellular internet cards. So, I mean, that's how old I am, right? You remember those ancient things? And I got up on the, I mounted them to the wall right next to a window, and I ended up running the internet off of those laptops throughout the company. And I had them in different zones, so different routers would go, or different switches would connect to different computers, so that they wouldn't all be sharing the same internet connection. And that's how they processed their sales for 3 days until the poll got fixed. Was a bunch of crappy laptops with PCMCIA wireless cards in there, and it's like, I told some of my friends that, and half of them were like, that'll never work. That's so stupid. Why would you ever do that? And the other half is like, that's a good idea. I'll remember that trick for next time. So you always got to deal with the crazy stuff that comes your way in all of these things, you know?
Yeah, that's. I think that those are really the things, like I've been facing it during my work as well. Like you really sometimes you need to be creative to make a solution. Even if it's temporary, temporary becomes permanent. And yeah, like at some point you really, you need to be creative working and especially in IT. That's otherwise it won't work.
Yeah, you just said something that describes all of Sega's designs from the 80s and 90s. You have to be creative with your temporary solutions, but make sure those temporary solutions don't become permanent. Otherwise, you'll end up with, a soundboard with on a ground plane that doesn't, that buzzes when you put it near something. So that's pretty funny.
And then you order a couple of million, and then you find out the issue.
Oh, that's funny. So, hey, thank you very much for taking the time to do this. As soon as I saw Tito's video, I messaged him immediately and said, hey, could you put me in touch with this guy? I really want to talk to him. This looks awesome. And I had a great time bothering you with these questions. I liked the whole story that you told was great. And I'm really interested to see the stuff that you come up with next, because, the way you approach it, your pick and place machine, the products that you've put out, these are all very cool things that I hope to see a lot more of you. And I hope to see your hobby of this grow as time goes on. So thank you for doing this.
Okay, you're welcome. Thank you for this.
Of course. So people can find you on Instagram, as well as your eBay store where you sell all of these things. And if they go to your eBay store and they can't find the boards, that just means they're out of stock, and you'll put them back when you get more stock, right?
Yes, like I had a very small batch because it's hobby, and I think I'm wasting already a lot of money on my hobby. So I make small batches of boards, because if they don't work, and it's simply waste of money. So I had only a very small batch of those boards. I assembled them, put them on eBay, and I think it was sold out in 3 hours or something. So there was a lot of demand for it. So I will order a new batch of boards, and most likely put them also on eBay. But it takes me a bit, to assemble them and to make them ready. But I hope in the next few weeks I have a new batch available.
Very cool. With the timing of this podcast, it might actually go out right about the time that you might have some available. So cross your fingers. But if you're listening to this, just keep checking the eBay store. I think you could add to favorite sellers or something like that. eBay changes all the time, but yeah, just bookmark your store and keep checking back for when they go up. And I'll certainly do a post on RetroRGB whenever they go live the next time again for people that want them. So make sure to put up a decent amount next time, because I'm sure there's going to be a lot of people interested that have single ASIC game gears. And I guess people that even don't, because they're cheap enough now where you could find broken ones where you could just kind of pick the ugliest ones that are all smashed up, buy those the cheapest, and one of them should be the single ASIC model. So.
Yeah, especially buy the ones where we have leaking batteries in it. Like those are the best ones to.
Yeah, because as long as it doesn't corrode through the main chip, you're good to go. So.
Most of the time, I had a few of them which actually had corrosion on the chip, but if you clean them really good, it actually turns out that the chip is still intact, and the pads, or the little legs are also still good. most of the time, this battery stuff is on top of it. Like when you start cleaning it, it comes off pretty good, at least from the chip. And it's worth a try. Huh? That's
Yeah, absolutely. Well, thanks again for doing this. I will keep in touch, and I will obviously be following your work and post whenever you have a new project up.